Hello everybody. Today I will talk about the interfacing in computer system. There are three different kinds of interface. First, let me talk about what is the interface. In computer system, an interface is a boundary of a computer system. We can use it to exchange the information. A hardware interface specifies the plugs, sockets, cable, and the electrical signals that pass through each line between the CPU and the peripheral device or communications network. As you see, here is a hardware interface model. Hardware interface has three different parts. Here is some data about the USB interface. A software interface may refer to a wide range of different types of the interface at different levels. API is one important part of the software interface. API is an abbreviation. It stands for Application Programming Interface. Generally, the goal of user interface design is to produce a user interface which makes it easy, efficient, and enjoyable to operate a machine in the way which produces the desired result. This generally means that the operator needs to provide minimal input to achieve the desired output, and also that the machine minimized undesired output to the human. Here is a link that make you understand this part better and easier.
Gets programmed. So what I'm going to show you now is what you'll typically see in a reference manual. You're going to look up a particular peripheral, and it's going to have some name. So, for example, this is called the warp drive unit, WDU for short, and it's going to tell you that it's going to have a certain amount of registers. Now, the first thing I want you to take a look at is it's going to specify the base address of the registers, and we're going to put it at 100 hex. And this is very common where we don't necessarily specify the address of each register. We're going to specify them as a base address plus an offset. And the reason we do this, in some cases, some peripherals, there may be more than one. So we just document the offsets, and then the system engineers who made the chip might put more than one copy of the same logic. So this is very common to see this base and then offset notation. And in a future video, when we talk about C data structures, it actually makes perfect sense why they do this, because there's some really cool ways you can use to program it. You may see something like this, like some name for the register, warp control, and it might be documented with some sort of mnemonic where the unit name underscore there's some other mnemonic for warp control. For example, we're going to have a set point register right here. So this is called WDU set. and we're going to have a status register called WDUW stat. And in each one of these cases, it's a base address from an offset. So, for example, the WDU stat is going to be at 0x0102. All right, and that's the physical address. Now, we're going to look at in a future slide of how we future video of how we talk to absolute memory locations in C. But for now, when I show these registers, just keep in mind that I'm just going to refer to them by this mnemonic. But we're actually talking to a memory address, a memory mapped peripheral. Because as I said before, everything in a microcontroller, all the hardware, is just a simply memory mapped peripheral. Now, in a data sheet or a reference manual, it's very common to see each register. They'll kind of lay it out graphically, like so. They'll mention its address, and here's some features you'll generally see. What they'll tell you is, the question is, what's the reset value, of this register, after a power on reset or something like a watchdog reset or any other reset source. And usually they'll show you, a bit like this bit, enabled dilithium reactor bit, starts at a 0, but the warp disables at 1. So you know what's its state after reset, because that's important to know. It'll kind of give a description or maybe another mnemonic of each of the functions. It may have some not used bits, or it may have bits that span or fields that span multiple bits. The other thing it might tell you is what you can do with that bit. Even though it's memory mapped, this peripheral's memory mapped, it's not like memory. It's not like you read and write for it necessarily. Some bits are. For example, warp and gauge is read or write. So if you write the bit, you can always read its state. For example, not used bits, write might no effect. It might always read as 0. It might tell you how it reads. It might read as undefined. It might not want you to read it. There might be some sort of undetermined behavior. And so you just look through these registers and you can kind of get a good idea of what it does. So what I like to do on any new peripheral is just look at the register set and how it's documented. You can get a good idea of how it works, just by looking at the registers. Now, there's not really any state information of how things are sequenced, but you can get a good idea of what's going to go on.